Alright guys, for section 5.3, again we are solving equations just like we did in section 5.2, but this time I have some imaginary solutions sometimes, as well as the real ones that we saw in 5.2. So here is problem number 1. The very first thing that you have to do when you're solving this is get everything on one side so it's equal to 0. So I've got to start out by moving that 3x over. To do that, I'm just subtracting 3x from both sides, and I get 2x cubed minus 5x squared minus 3x equals 0. After I've got everything on the same side, we're going to factor completely, just like we did in the last section. So, what is my very first rule of factoring always? Okay, so we're going to start with that. Do I have a greatest common factor?
Yes.
Yeah, it's an x. So put my x out front, and that will give me 2x squared minus 5x minus 3 equals 0. And now you've got to look at this trinomial right here. I can factor it. What method do I have to use? Bottoms up, yeah. So to do that, remember you're going to take your 2 times the 3 out here. And that's going to give me x squared minus 5x minus 6. That will factor into x minus 6 and an x plus 1, because they have to multiply to be negative 6 and add to be negative 5. Okay. Once we get to here, you have to finish bottoms up. Come back and divide by that 2. So I get x minus 3 and 2x plus 1. The other thing you've got to remember to do is this x that was out in front, you got to bring it down. Once you get it factored completely, just like we did in the last section, you're going to set the factors equal to 0. So x is a factor, x minus 3 is a factor, and 2x plus 1 is a factor. Okay, x equals 0 is already solved. Move my 3 over for this one. And there's the last one. My solutions are 0, 3, and negative 1/2. Okay, hopefully that one wasn't too bad. Anybody still copying? Yeah? Okay. Alright, so guys, here is part B. Go ahead and start it just like you did the last one. Move everything to the same side. But when you move that 6x cubed over, pay attention to your standard form and descending order. Okay, if you didn't put it in the right place now, that's okay. You just have another step where you put it in standard form. Okay, but if you remember it here, it's one less step for you. So now what's my first step from here? Greatest common factor, which is what?
3x squared.
3x squared. And that will leave me with x squared minus 2x plus 4. And now I've got to look at this trinomial and see if I can factor it. Okay. Do I have any numbers that will multiply to be 4 and add to be negative 2? Which ones? No, unfortunately. Now, last block, we tried a lot of different numbers that definitely don't add up to negative 2. But it won't. So we have factored this as far as we can, because this cannot factor. Well, we haven't solved for x yet. But I'm done factoring at least. When I'm done factoring, remember, you've got to set each of your factors equal to 0. Alright guys, once we get to here, I've got my factors set equal to 0. Now I have to solve both of those. So over here, I'm going to divide both sides by 3. And I get x squared equals 0. Take the square root of both sides. And technically, I get x equals plus or minus 0. But is x positive or negative? No. So basically, I've got the same answer twice. So x equals 0 has a multiplicity of 2. But now I've got to solve this one. I can't factor it. There's no way I can get x all by itself and only on one side of the equals sign. So we got to figure out another way to solve this. Okay, remember, we just finished chapter 4, where all of the problems were x squared. How could I solve an x squared equation? Is that?
Did you take the square root of x squared and 0, and then...
Nope, I can't take the square root of parts of the equation. It's got to be everything on one side and everything on the other, or you can't do it at all. Addison?
Subtract 4 to the other side, divide negative 2 by 2 and square it, and add it to both sides.
Okay, so that's completing the squared. That works. Yeah? Chloe, do you have something else? No?
Oh, graphing.
Okay, you could try you could try graphing, but rather than let me use some different terminology here. Instead of saying solve an x squared problem, isn't this a quadratic equation?
I was thinking that, but I didn't want to sound dumb.
You should have said it, and then they'd have caught you being smart on video.
But then,
So we could use the quadratic formula, but you can also do completing the square. So, what I want you to do is I want you to solve this by either completing the square or the quadratic formula, whichever one you want to do on your paper. I'm going to pause the video, I'm going to freeze the screen, and I'm going to work it both ways. Okay, and then we'll turn it back on and compare. Yep, commercial break. There we go. Alright, so at this point, you can see, right here, I have solved it by completing the square. Over here, I did the exact same polynomial there. I factored it, or solved it, using the quadratic formula. I got the same answer. Doesn't matter which way you do it. You get the same answer either way. But now, we got to go back and make sure we've got all the answers to the original problem. Okay? This was my original problem. This was the factored form. When I worked those, I got this answer as well. So, my answers are x equals 0 with a multiplicity of 2, And I also get 1 plus or minus I square root of 3. Yes?
Can you write it as x is equal to 0, comma 0?
You can list the 0 twice. I'm fine with that. So here's the thing. When you get done, you need to make sure you've got the right amount of answers. Back at the beginning of this problem, what degree was it? Say 4th degree. So I should have 4 total answers. Right here, 0 with a multiplicity of 2 is 2 answers. How many answers do I have right here? 2. So 2 answers and 2 answers is a total of 4 answers. We got them all. Anybody still copying or checking here?
Wait, I got it.
All right, next. Okay, once again with this problem, we want to put everything on the same side so that it's equal to 0. And now I want to try to factor this. The difference in this one is my first term is an x to the 4th, and I don't have a greatest common factor this time. But I don't really have to do anything different. What I want you to notice is the exponents. This one is an x to the 4th. The one in the middle is an x to the 2nd. Well, 2 is exactly half of 4. So all we're going to do when we factor this is go ahead to your 2 parentheses, and this time, instead of an x to the 1st at the beginning of each one, I'm going to have an x squared. Because x squared times x squared will give me x to the 4th. Once I've got those x squareds in my parenthesis, I don't have to worry about my x to the 4th or my x squared anymore. I just worry about the numbers. So to multiply and get a negative 4, do I need 2 positives, 2 negatives, or one of each?
One of each.
One of each. Which one's positive? The 1 is positive and the 4 is negative. Can I factor either of those parentheses again? Yes?
On the right.
I can factor this one because it is what kind of factoring?
Square root.
Difference of squares. I can't factor this one again because it is a sum of squares and there is no such factoring. So I'm just going to keep this one and then take my x squared minus 4 and factor it. That's going to be an x plus 2 and an x minus 2. After you've got it factored, set all of your factors equal to 0 and solve. Alright, when you are done, check yours with mine.
Could you write it as, just write both of the 2's?
You could write both of the 2's. You could even separate out the i's and write a positive I, comma, negative I, comma, positive 2, comma, negative 2. Yeah, either's fine. Are you just stretching back there, Lawrence? Yeah, okay. Anybody still working on this one? And I have a question about it. All right. So now we have an x cubed problem. Part of the answer is 1. There's more than just one answer. How many answers should I have?
I'm assuming 3.
I should have 3. And this one has some that are imaginary. And you can't find that if you just take the cube root of both sides. Okay, remember when we took the square root of both sides, we always did plus or minus, so we got all the answers. I can't do that for an x cubed. So, move everything to the same side. And now I've got to try to factor this. You remember the factoring we did right before we started this set of notes? The difference of cubes. Let's see if this is a difference of cubes. Okay, difference because it's subtraction. Can you take the cube root of x cubed? Yeah. Can you take the cube root of 1? Yeah, what do you get? 1. So I can factor that. Remember, it's going to give me a binomial and a trinomial. So in my binomial, what do I put first? X, because I just take the cube root of x cubed. What goes next? 1. In my second parenthesis, what's my first term? X squared. Next, 1x, and you can write 1x or you can just write x. And my last term in that parenthesis is 1. And now we've got to use SOAP to get the signs. Started out negative, so I'm going to do the same. Opposite, always positive. So now, this parenthesis has an x squared in it, and the thing is it will never, ever, ever factor any more than that. Okay, since I can't do any more factoring, I'm going to go ahead and set it up so that each factor is equal to 0. And now I have to solve those. First one's easy enough to solve. I get x is 1. What about this one?
Factor.
Well,
Can't you do x?
You can use the quadratic formula. You could try completing the square. I would for this one, because my middle term is not an even number. That means I'm going to have to deal with lots of fractions if I do complete the square. So do this one using the quadratic formula. I'm going to pause everything, freeze the screen up front, and then we'll come back and let you check it with mine in a minute. Alright guys, so when you have finished, look back up front, check yours with mine, let me know if you have any questions. Alright, we've got 2 more, and for the most part they are just like the ones we've done. But before I give you your assignment, I want you to try 2 more pretty much on your own, and then you can double check it with mine up here when you're done, and then I'll give you your assignment, and that's it for the day. Okay? So there's the first one. Okay, I'm going to pause everything while I work it and you work it, and then we'll come back together and check it. Alright guys, so I've got my work up front, and what I did is I took this second parenthesis, that trinomial, and I solved it 2 ways. Over here on the left in blue, I did it by completing the square. Over here in green, I used the quadratic formula. I got the same answer either way, so it doesn't matter which way you do it. Do which way makes you happy. For this problem, I think completing the square was shorter and faster. But if you don't remember it or don't like it, do the quadratic formula. Okay, how many of you are still working on this one? Okay. if you have finished it, I'm going to slide this up just a little bit. Go ahead and start working on problem number 2. Okay, and we're going to start out by just moving that 9 over, and then see if you can factor it and solve. Alright, when you finish problem number 2, go ahead and double check it. Once you factored it the first time, you could have finished it exactly the way I did. However, you may have done it a little bit differently. If you did it differently, let me know, and I'll be glad to put it up here. Yeah.
Okay, so I used the quadratic formula, and then when I got my final answer, which would have been 9 and 1, I just took 9 and I squared it because I knew that if that would be x squared, and I knew that it was x to the 4th, so I would just square it a second time to get the answer. And I got the right answer.
I don't know if that would work every single time. It might, but I don't know for sure. You want to let me do a little bit of investigating and try a few extras and ask me that question again on Tuesday, and I'll let you know. Because I hate to just jump in and say, oh yeah, that works, and then find one oddball case where it doesn't. So, yeah, Cody? Yes. Okay, anybody have any questions? All right, so, homework time.